So let's come to unit number 8, compound noise factors. Even though that we're already using outer array to reduce the number of sampling, instead of random sampling, we use outer array sampling, so we can consider all the influence of the noise factors. However, it still needs a certain number of samples. In our example, if you are using L4, you can only consider 3 noise factors. If you want to consider more than 3, such as 4 noise factors, you need to use L8. That is in our last homework. We are using L9 as the inner array, L8 as the outer array. So the total samples will be at least L9 multiplied L8, which will be 72 samples. It is still a lot. If you say each sample will take, for instance, say $10,000. $10,000. If you are actually manufacturing a bar and to test it, it might cost a lot, especially it is in the Western countries. So we want to reduce the number, but still remain a good estimation of the range, which stands for the standard deviation and also the average output. So that's the reason why I want to see if we can further reduce the samples to maybe 2 or 3, but still can have a very good estimation of the mean standard deviation. Therefore, we can still have a very good estimation of the SN ratio. So let's define what is compound noise factors. For compound noise, for this is the output. This is the target output. As I mentioned before, the reason why it will have a distribution are due to the influence of noise factors. So if we can find out what combination of those noise factors, and it will push our output to the maximum numbers, we can call it compound noise factor plus. And also another combination of the noise factors, which will push our average, which will push our value to the lowest bound. We can call it compound noise factor minus. Then we can only just use these 2 combinations of the noise factors. We can come up the upper bound and the lower bound of the output distribution. This is the ideal case. This is the ideal case. In case we need 3 level, we need 3 level to estimate the distribution. The 3rd level, or I should say the center level, will use the nominal output, which means that assume there will be no errors or no influence of the nominal value of the noise factors, which will make it the 2nd level. Level 1, level 2, and level 3, if you want to use 3 level. But in most of the case, we often just choose 2 level. All right, so as you already see here, if you are using 2 level, okay, right here, first one is pushed to the level 1 lowest, and the high level will be the highest. If you are using 3 level, right, another level, the center level will make it to the middle value of the noise. Middle value of the noise. If they are manufacturing error, will be the nominal value. If they are the range of noise factors, such as environment, outer noise, it will be the middle value. All right, let's use one example, this bathroom scale. Bathroom scale. Okay, you can measure your weight, body weight. But you will find out that the measurement will have small variation when it depends on what kind of type of floor you are putting your bathroom scale. You can find out it is a hard floor like a wood floor or the marble like this one. Your measurement tends to be a little bit higher than normal. If you put your scale on the thick carpet, on a thick carpet like this one, the thick carpet, then you will get a value a little bit lower than the normal value. The second noise will influence your measurement is the position you stand. If you stand at the middle, right here, right, stand in the center, in the middle, you tend to have a higher value. If you stand at the edge, okay, like you stand on the edge right here, it tends to have a smaller measurement. So consider only two noise factors. The first one is the flow type. The second one is the position you stand on the bathroom scale. You can find out that if I N2, which means that if I put my carpet, put my scale in a thick carpet, and also I stand on the edge, this noise comparison will give me the smallest output, smallest measurement of my body weight. However, if you put it on the half row and also you stand in the middle, then this combination of the noise, since they are all noise, right? You cannot control the customer, the user, where to stand or where to put their bathroom scale. So, but for a designer, you can find out these two extreme conditions and try to come up these two combination of noise. This first one will make it the smallest output. Second one will make it the largest output. So this is how we select the compound noise factor. If you already know the direction, so this based on you know what is the influence of the noise on the average output. How do we know the influence on the noise to the average output? If you have an effect plug like this one, but this effect stands for the noise. If you know the effect plug like this one, you will know delta H is the influence of the thickness, delta L, the length, delta B is the width. As you can see that these three noise will have the influence like this one. Therefore, if you want to pick the first combination in such a way that the average output, which will be the K, will be the minimum, then you will pick delta H1, delta B L2, and also B1, right? How about the second level? What will you choose for the second level? I think it will be very obvious, which will be the opposite, right? H2, L1, B2, like this one. Okay, so ideally, we just need to use two combinations that we can estimate what will be the minimum and the maximum output for our design. This is a concept. But the problem is, how do I know the direction of the noise factor? How do I know the direction of the noise factor? Okay, well, we already did one outer array, right? In the previous chapter, we make our noise factor in an outer array. And from this outer array, we can estimate the output. But we can also use that outer array and using analysis of mean to find out the effect plot of the noise factors. Just like this one. This is the classroom example, L9 and L4. Later on, we will work on the L9, L8 example like what you did. So here, we just need to do one sample, right? We want to find out the direction of the noise factor. So let's take the first one. Any combination will be fine. First example or the initial design and apply this noise to that particular design, we can get the output sample like that. And this is one of the example in our previous lecture example. And instead, we pull that outer array out. This is the first set of sampling, right? L4, and this is the 4 output. and they are controlled by the 3 noise factors. This is outer array. Using a similar scale we did on the control factors, we can find out what will be the effect plot for the noise factors. So from this one, we can find out this combination, all right? Delta H1, delta L2, delta B1 will give us the lowest output. So this will be the compound noise level 1. Same thing. This red circle right here, this one, and that one will stand for the second combination of the noise factors, which will push the output to the highest value. Therefore, this is how we select 2 level. In case you want to choose 3 level compound noise, then the lowest number will be the level 1, and the second level will make, because they are all manufacturing error, right? We'll make our manufacturing error to be the nominal value, which will be the middle value. So make it 0. And the third level will make it the combination of the noise factor that will push the output to the highest value. So in case you need to use 3 level, this is how you make 3 level noise factor, compound noise factors. Right, so that's when we do the sampling. Similar to the previous example, the inner array still organize the control factors into one orthogonal array, and each combination will be called a design. When we want to sample the output instead of a random or orthogonal array, we are using compound noise. In this case, we are using 2-level compound noise. 2-level compound noise. Therefore, you can see each design will have 2 samples. First level and second level. We apply this noise on this design and get the 2 sample output. From these 2 sample output, we can get average, standard deviation, and noise SN ratio. Similar scheme, we can go through each step, all right? Go through each design, and we can get all the SN ratio, like what we did in the previous inner-outer array combination. So this is the experimental array using compound noise. You only have 2 combinations, and you can have the SN ratio. As you can see that the SN ratio value will be slightly different. Okay, if you look at here, SN value will be slightly different. Since we are using 2 different strategies, one is orthogonal array, one are using only 2 samples. Which one will be more accurate? Which SN ratio estimation will be more accurate? Orthogonal array or compound noise? In your example, 4 noise factors, how many experiments in your outer array? 8, right? But here, if you are using compound noise, you only use 2. There are no free lunch, which means that one sample you only use 2, the other sample you use 8. Which one will give you the better estimation? Certainly L8, right? Since you have more samples, and these orthogonal array samples will be well distributed in this design space. I'm sorry, the sampling space. So it will be better than the compound noise. So that is the reason why the SN ratio are different from our previous experimental design. But this one still can be used as a reference, because the reason we want to have this SN ratio is we want to, draw the effect plot for mean and the SN ratio. You can have these 2 effect plots. As you can see, effect plots are slightly different from our previous example. Next, this is a nominal the best, so we want to classify into 4 types of control factors. In this case, you can find out that some might be a little bit confused. This one is still type 3, but these 2, the influence of the L and B on the SN ratio seems increased. They have some influence. unlike our L9, L8? Well, I would say this is because this is only a estimation. And this estimation using compound noise factor will not be as good as outer array, but cheaper, right? So the next one still, you want to find out which one could be the scaling factor. Even though this one is a perfect type 3, but this one, Young's margin E, cannot be a scaling factor. How about B and L? Well, they all have some influence, right? On the mean, but the SN has some influence. Some might choose B, since B has a smaller influence. So if you want to choose one factor as the noise factors, then B could be the scaling factor. But when you work on the adjustment, you'll find out that if I use B as a scaling factors, when we change the B, it will go outside of design range. Then we can come back to the second choice. We don't choose B, we choose L, even though L doesn't look that good to be the type 3, but just like we need to always pick the one apple to be the mayor, right? We need to choose one apple, the best apple to be the scaling factor. So this one cannot do the job, so we'll go to the next one, which will be the L. So do the similar adjustment, you can find out the optimum design after two-stage optimization, and you find out that the result will be similar to our previous example. Okay, I will work on that using Excel file. And there are some conditions for the compound noise in order to apply these compound noise factors. First, as I mentioned, those noise factor has to be the major noise factors. There are so many noise factors you found to include everything in. Then your experiment might become very big. So he suggests that you only work on those important noise factors. So this is the first assumption or the requirement to use compound noise. The second one is you need to know the direction of the noise factors. How do we know the direction? You can use one outer array, work on the initial design to find out the influence of the direction. And why do you choose any design? In this case, why do you choose initial design? Because in the third requirement, the direction of the noise factors cannot depend on the setting of the control factors, which means that no matter which design you choose to analyze the outer array, the direction, the effect plot of the noise factor should remain the same. Otherwise, your assumption that the compound noise, one lowest, one largest, will fail when you apply to different design in the inner array. Okay, at last, you need to verify your result. Okay, let's use the Excel file to be the example and try to follow you through the homework. This is the homework. And as you can see, it is pretty much the same example like what we did before, right? But here, okay, they are pretty much the same. Almost the same until here, A, B, C. So you already know the answer because you already done homework number 4. So the answer for the first 3 will be pretty much the same. But the next one is the noise factors. Now you want to consider the noise factors. The noise factor, he asks you to set the noise factor, the level of the noise factors. In our previous example, I didn't remember we asked you to do that. Where is it? This one. In our last example, right, we are focused on the control factors, right? And the noise factors we show you already. The noise will be here. So we just set the lower level and the upper level. But in this example, you ask you to write out what will be the level 1 of each and level 2 for each noise factors. Okay, so here, let's go back to the example. We can use our previous example as a template, as a template. But ideally, you need to design everything by yourself. But we can use this one as a template to work on our next homework. So you can still open this file, but let's what? Let's save us a new file. Let's make it L9 and CNF. We are using L9 and compound noise factors. This is next homework. Okay, for instance, just make it another file. Okay, now we want to move just a little bit. First, he asks you to find out the level of the noise factor. I think should be very easy. Let's say put it the noise factor, because we want to work on the noise factor. So right now, you had better know what will be the level 1 and level 2 for your noise design. And here, we focus on what? We focus on one, I should say that we want the level 1 to be the small value, level 2 to be the upper bound value, okay? 0.05 is 5%, but I can use percentage here. So you'll be a feel more consistent. Okay, any question? Okay, now we need to find out the direction. We need to find out the direction of our noise factors. That was the direction of our control factor, right? This is control factor, but we want the noise direction for our noise factors. How can we do? How can we do? Okay, you need to forget everything here. You need to forget everything here because we haven't done anything here. We want to design our experiments. So we need to find out what will be the direction. That is the second question here. We already set a level, and we need to select a suitable outer array. We already did that, right? L8, the same as our previous example. Now, it asks you to work on the outer array on the first design. Let's change a little bit on the initial design. Let's change this one a little bit because in our textbook, we work on the initial design. Let's work on the initial design. That's okay, right here. Please change your homework. We want you to work on the initial design and using analysis of mean to find out the direction on the noise factors on our average output in order to make a compound noise, all right? So you want to make an outer array, which will be L8. So from here, basically, this will be L8. This is L8, right? This is L8. Let's copy this one to a new page here. What should I do? Okay, make a transpose. So this will give you, did you notice what I did? Okay, so please follow me. I want to, in the real world, you need to do everything by yourself, but we already did that L8 before. So I want to just copy our previous example over. So save you some time. So we copy here, but when we work on the closed array, this one is a transpose, right? Transpose for L8. Doesn't look like our previous control factors. Control factor is do this way. So we need to transpose that outer array back, right? So we copy that to the new Control C, copy. And when we go to the new worksheet, we use, let's do that again, right click. Okay, sorry. Here, copy. When you come here, pick, select it, post it. Select it. We want to post what? We want to post the value only, and also we want to transpose. So we can transpose our outer array back to its normal setting. Okay, so this is the outer array. Let's we can insert another array so you can know this will be L8. And this is experiment number 1, 2, 3, 4, 5, 6, 7, 8. Right? So they are L8. Look more familiar to what you tried before, right? And here we want to work on the initial design. Initial design. Work on the initial design, the output K of the initial design. But here we only copy the format, right? As you can see, there are number here already. They are same, but it is easier, more familiar to put it on the left side. But what will be, since we want to apply this noise to the initial design, what will be the output when this noise applied to the initial design? The output is right here. This is initial design. This is the L. This is the L8 output for the initial design, right? So you want to copy this number over here so you can find out what will be the output. Again, when you put it, you want to use disappear again. You want to copy, and when you come here, right click, you just want to select it output, and you want to put the value only. Otherwise, you will be post the equation. You want to put the value only, and you want to make it transpose. So this will be the 8 samples for the initial design using L8. Any questions? Just like what we did on the control factors, you arrange all the noise factors. Right now you have 4 noise factors into this L8 array, and by applying this noise to the initial design, you can get the 8 simple output. So this is the 8 simple output. From here, you want to analyze the average output. So just like what we did before, you want to do the effect plot, response curve, this response table. All right, let's make it easier. So let's E1, let me copy that here. E1, level 1, and this will be level 2. Average output, level 2, and I make it horizontal so we can see the number. Otherwise, it will be too long, right? And this will be 1, level 1, delta level 1, delta L level 1, delta B level 1, and the copy or type level 2. When I put a number over to the next one, you will be smart enough to know the next one will increase the last one to be 2. So I don't need to type it. You will automatically fill in the number. So this is the response table for the noise factors, level 1, level 2, for all these 4 noise factors. Now you need to find out what will be the average output. It is the same like what we did before, but this time we are working on the noise factors. Average if data, the level 1, low level, and the corresponding output number will be this range, and you can get the average output for delta E1. Same thing, okay? You can work on the same for the rest of the noise factors. After you finish these noise factors, you can draw the effect plot for this response table. Next, you can draw the effect plot. Remember something? This is the K, okay? Effect plot of noise factor. This is not signal to noise, right? This is only K. What will be the influence of the noise on the output K? So you can draw the effect plot. Once you finish the effect plot, it will look like this. Okay, it will look like this one. This is a noise factors on the output K. Okay, and this effect plot will show you the direction for each noise factors on the output. Right? Then you can, from this observation, you can find out if I want to choose a compound noise factors, what should we choose? The compound noise level 1 will make our output to be the lowest value. Therefore, E will be the E1, L2, H1, B1, like here. So this will answer the homework questions. Okay, I apply the outer array on the initial design using analysis of mean to find out the effect plot of the noise factor. Therefore, I can come up the compound noise factors, level 1 and level 2. What kind of combination should I use for these two levels? Any questions? If you have any questions, raise your hand. So you should find out what will be the inference direction for each noise factors. You can try it. Right now we are working on the initial design. If you work on the initial, instead of initial design, if you use the first design, if you are using the first design to come up the effect plot, you can compare whether they will be the same or not. They are supposed to be the same. Let's try. For here, this is effect plot on, I'm not sure which one this is it, 1.21. Okay, 1.21. Okay, this is not the initial design. This is the initial design output, right? Copy. And the number I use in this example is the first design. It's the first design. Let's try. If I replace the output of the first design to the initial design, what will be the output? Will be the same? Let's put it here. Okay, this is the number, right? And this is the number. Sorry, this is the number, right? Design number 1, right here. I can change it. I can replace it. I replaced our initial design, just like what we did, right? Okay, this changed to the initial design. And let's look at the figure. The direction are the same. This is the questions. The direction should be the same because we are using this direction to come up the compound noise. If the direction change, when I change the design from the initial to the design number one, if the direction change, then our compound noise factor assumption will not hold. Okay, if you didn't remember what was the previous curve, let me use Control Z. This was the initial the effect plot for the first design. And if I use the initial design, this will become the curve like this one. They are pretty much the same. The direction are still the same. So the first combination, noise one, will be E1, L2, B1, H1, B1. So the combination was still the same. Any questions? 有问题的举手哦。好。Any questions? So I believe this is the value you should have. That was the that was the outer array orthogonal array. That was the outer array in the closed array arrangement. I transpose that into this one. So this will be more familiar to you since this is how we work on the control factors, right? Control variable, experiment number, and so you can calculate the response table and then come up the effect plot. All right, any questions? Therefore, this is how you get the compound noise combination. Let's put it here. I believe you should know how to do that, okay? So this will be, for example, okay? This will be our, you should explain how to do that, right? I just copy that over so you can know what will be the result. Any question so far? How do you obtain the compound noise level 1 and compound noise level 2? Any questions? Okay, I figure out that the problem might be a little bit different because that the arrangement of the noise factors in that particular example, in this one example, is different from the one we are asked you to do. So just follow your own effect plot. Since the arrangement will be different, but the direction will remain the same. So the curve may not be exactly the same like this one. I look at your results, you can find out that the arrangement of these four factors are different. But the most important thing is the direction are the same. If the direction are the same, then the conclusion will be the same. The conclusion for the compound noise will be the same, okay? So don't be confused why the arrangement of the figure, the effect plot is different. This is ELHB. Let me see what I did this time. EHLB, okay? So the arrangement are different, okay? So the curve, your curve should be the correct one. But no matter which curve you use, your conclusion will be the same. The compound noise level 1 will be the combination of the noise factors. They will push the average to the lowest. Same thing, noise 2 will push the average to the largest. Although I didn't finish the table, but I finished half of that. So you have to be very familiar with how to come up the response table and effect plot, since we did that all the time. Yeah, I typed delta, but if you want to use a symbol, right? If you want to use symbol, you can find out here. You can insert and symbol has to be delta, right? Delta is the Greek number, Greek number here, Greek number, and you can see delta, right? So you insert delta, then it looks better. Or you want to put it here. Okay, delta B1. Oops. Hmm? Oh, no equal sign. Okay. But it doesn't matter, okay? This don't need the delta. Delta B1, delta B2, delta H1, delta H2, okay? So it might look more concise, more not as long. I can just use a symbol here. Any questions? Any questions? All right. Once you finish that, we need to work on the experimental design. But in the previous homework, we are using inner array with outer array. But we need to replace the outer array into only 2 samples using compound noise factors, right? So let's adjust our experimental array a little bit. 谁还没有完成因子折线那个什么那个干扰因子折线图分析的，还没有完成的举手一下。还没完成就都完成了。好，那接下来 OK next we need to change our experimental array into inner array and compound noise. The outer array will have 8 samples, right? 8 samples, but too many. So want to reduce it. Therefore, let's keep only 2. Keep only 2. And we can reduce, or we can here, select up here, okay, up here. Only keep the first 2, but erase, which will be delete. Okay, yeah, I should use this one. Right click, choose erase, delete, but here you choose move to the right, to the left. Move the rest of the cell to the left. Therefore, it can move everything else, average and standard deviation over. Okay, this is only some tricks. Next, you want to modify a little bit. You have 2 levels, so this will be compound noise level 1. This one will be compound noise factor level 2. Okay, now remember we need to go back to our analysis, find out what is the compound noise level 1 and level 2. Let me copy that over so easier for you to double check. Let's put it here. Our compound noise level 1 will be the 1121, only L to be level 2. So now you need to adjust it. Level 1, I'm sorry, L to be level 2, right? No, that's okay. But BLHE, whatever. This order might be a little bit messed up. I thought what I did was right. It will not influence our result, but I just want to make the order to be the same, right? ELHP. So you can see that in the compound noise level 1, they are all in level 1 except length. So here, make sure in the first sample, L is in level 2. This is a compound noise 1, right? Level 1, here, 1, 2, 1, 1. And in level 2 of the compound noise, it will be 2, 1, 2, 2. Only L to be in level 1. So here, B level 2, so it is plus L level 1, good. H level 2. E level 2. Okay, so now we are make sure that our outer array become the compound noise samples. We are using only 2 sets of samples. The first set of sample, compound noise 1, we obtain from our analysis of mean using the noise factors. And we find out this combination will push our output K to the lowest value. And this one will push it to the highest value. Since I'm using this trick, so all the equations still remain the same. So we can see the data right away. You don't need to retype the equation. But it should be not that difficult in case you need to retype the equation. It is the same as what we did last week. This one, we need to consider the influence of each noise on this control factor. So B has to be plus delta B. H has to plus delta H. Same thing, L and E. Then you can get the first output for the control noise factors. When you compare these two, you can find out that for the compound noise level 1, they are all smaller values. If you compare the compound noise level 2, they are all the bigger value. Okay? In case you go back to the original problem here, if you go back to the original problem here, to what you did last week, you can find out that that combination will be, the minimum and maximum will be the same here. The minimum will be which one? This one. This one is the minimum, right? In L8. And you find out this one is compound noise combination 1. Which one will be the largest? The largest may not be in L8. It's in L8, let me see. Plus, minus, plus, minus, minus. No, it's not in here. It's not here. But as you can see, the largest value right now is 1.437, this one, right? But let's go back to our outer array. 1.437. I believe this should be bigger. Oh, the same. Okay, right here, this is the biggest value. So you can see that in our outer array, we only keep the lowest and the largest, the smallest and the largest. So we can find out what will be the range, the distribution range, very quickly, only use 2 samples. The reason the compound noise will give us 2 samples, which minimum and out maximum. Therefore, we can calculate the mean. Here, as you can see, the mean only calculate the average of these 2. Same thing, the standard deviation only calculate from these 2 samples. Therefore, we are using the same equation to get the SM value. get the SN value, all right? So this is the experimental design using inner array and compound noise. If you look at this experimental design, you can find out that the design is much smaller. You only make how many samples? Here, you only make design experiment. How many samples did you do? You pick L9 and multiply by 2, right? Since the compound noise factor, you choose 2 level only. So there are only 18 samples. Only 18 samples. However, you still need to consider what? The sample you use to find out the direction of the noise factors, right? Plus the outer array, right? So you have L8, this one. So 18 plus 8, right now only 26. All right, right now you are using 26, L18 for the experiment, but L8 here, L8 here, right? This costs money too, L8 at the very beginning, to find out the effect plot of the noise factors in order to make the compound noise factors. So there will be 8 plus 6, 18 plus 8 will be 26 experiments compared to our outer array. In our outer array, how many experiments we did? 9, 8 will be 72. So in the outer array, L8 multiplied by L9 multiplied by L8, this will give you 72 experiments. But right now we only use 26. In addition, you might need to do some verification of your output, okay, or the second stage optimization. But for both problems, they will go through the same process. But in the initial design, L9 by L8 outer array took 72, but right now we only use 26 samples. Save you a lot of time by using this outer array, by using compound noise instead of outer array. Any questions? Any questions? Okay, next, continue on the problem. Let's look at the question. What the next he asks you? He asks you to use inner array and compound noise to do the experimental design. This is what we did here, right? This is the experimental design, okay? You can copy that over. And then next, he asks you to find out the data. We did that already. And find out the response table and effect plot. Okay, find out the response table and effect plot on the SN ratio and the mean, just like what we did before. So they are very straightforward. If you still have the data before, if you still have the data before, this is the trick I show you again. I keep the original data so you can find out that the effect plot will modify automatically, right? Since the effect plot here, level 1, level 2, they are using the data over here. So I delete the middle cell and move the equation over so it can still keep the same equation when you get the effect plot for average and SN. And you can see that these two effect plots are very similar to the one I just show you on the transparency, on the class node transparency here. See? They are almost the same. They are almost the same. Because this is a textbook example, This is a textbook example. So even though in our lecture notes, we only consider 3 noise, we only consider, I'm sorry, even though in this, okay, sorry, I messed up. So start from here, you need to work on the 2-stage optimization problem, just like what we did. Now you need to classify these control factors into 4 categories, And here, in the next questions, you need to use the first stage optimization. Find out what will be the optimum combination that will give you the maximum SN ratio. It's the same. So from the first stage optimization, I believe the best choice right now, the maximum SN ratio right now will be the same. Look at here. Will be what? Maximum SN, right? B3, H3, L3, and the last one is E1. Okay? Well, so from the first stage optimization, the combination will be the same. Level 2, only Young's modules will be level 1. So you find out that you have the same conclusion, like L9, L8, right? Like the L9, L8. But you didn't use 72 experiments. You only use 26 experiments. You find out the same conclusion. The first stage optimization, okay? You have the same conclusion. That is the beauty, or that is the purpose by using compound noise factors. You can use a small sample to find out which combination will give you the maximum SN. No matter it is a smaller the better, nominal the best, or larger the better. They'll be the same. But if it is nominal the best, you need to go through a second stage optimization. The second stage optimization, again, we start from our original design of the first stage optimization. Okay, they are the same. Now you need to pick one. You need to pick one variable to be the scaling factor. As I mentioned in the lecture notes, from the effect plot over here, you need to classify this into 4 categories. And right now, the conclusion of H is still the same. H is type 1. Okay? Young's modulus is type 3, no problem. However, B and L, they are not that perfect as a type 3. So I say it's a type 3 like type 3, but not exactly type 3, because they are still have some inference. Some of you might think L looks better like type 1, right? Type 1 will have inference on the mean and inference on the SN. So L more like, okay, here. So that's the reason why I say type 3 or type 1 like. It might look like a type 1, since if you consider this to be a significant inference, right? We said that whether L has some inference on SN, I believe if you look at the curve, you will say this is better look like type 1. And B may like type 3, or could be a type 1 as well. Now the problem is you need to choose one to be the scaling factor. How comes this plot is different from L9, L8? Because you only use 2 samples. This is the price you pay. This will not be that accurate like L9, L8, but good enough for you to make your decision. So here, you need to pick one to be the scaling factor. Which one will be the scaling factor? Well, just like what we did before, when you choose E cannot be a scaling factor because it is discrete variable. So the only choice you can have is maybe start from B. B looks better than L. Although there is no perfect type 3, but you still need to pick one control variable to be the scaling factor. So since E cannot be the scaling factor, now you need to consider if B could be the scaling factor. Okay, let's come back here. Can B as the scaling factor? Let's try. All right, this is B. Can B to be the scaling factor? Let's try. Let's try B to see if we can make K equal to 1. Again, which direction should we try? Should we make B bigger or smaller than 6.6? This might be the question I will ask you in the midterm. Which direction should we choose, should we try in order to make K to be bigger? Right now it's 0.89, too small. We want to adjust it in order to make it bigger. So should I pick a number B to be a bigger B or smaller B? Bigger or smaller? You can look at the effect plot. If I want to increase B, increase K, should I increase B or decrease B? Should I increase B or decrease B? Increase, very good. Why should we increase? Since in this effect plot, this is B. We know that if we increase B, K will increase. Therefore, we should increase B. Now we face into a problem. What is the range for B? Level 1, 4. Level 2, 5.3. Level 3, 6.6. But if we increase B, this will be go outside of our design range, right? Can you go bigger than 6.6? This is something you need to consider. So in this case, you can find out that even though B could be the better scaling factor, but if I use B as a scaling factor, the adjustment will go outside of the design range. Well, you cannot choose E. E is discrete. You cannot choose B. B will be out of range. What next? You can only come to the third candidate, L. Well, it seems we can only adjust L, even though the effect plot shows us that L doesn't look like that good as a scaling factor, right? Because they have some influence on the SN ratio, but you have no choice. So again, you choose L, and then you adjust L. Let's try 53, all right? Not big enough, not small enough. Let's try 52. Okay, I'm sorry, 52. Okay, perfect. Then you find out that I can choose 52, so K will be closer to 1. You can try the second decimal and third decimal, but you can find out that 52 is still the best answer. even though I choose say, it is not necessary to be an integer. It could be a smaller number, like a 0.1. What happened? Too small. All right. 1.9. Too big, right? It's not any better than this 0.008. So you can keep try and error. You can find out that, well, 52 2.0 sounds better. You can try the second decimal, 0.01, but unless you can control your error to the second decimal, but I think this one should be good enough, right? Right now, it's 1.0024, could be a little bit better than this one. Okay, this is 0.03. If I choose 0.01, could be better. Okay, let's choose 0.01. Right? I believe you cannot get any better unless you go to the third decimal. So this one you can get 52.01. You move your average to the target 1. Okay, although there are small errors, but let's look at the SN ratio. The SN ratio for the first stage optimization was here. Okay, you can see 16.99. After the second stage optimization, it dropped a little bit to 16.96. But if you compare this one with the rest of the L9, you can see that this is still very good. Still very good. So even though L is not a perfect scaling factors, but in this case, we still use L to move our average to target. Only a small drop in the SN ratio. Any questions? Now the purpose is if you compare the whole process we just did with our previous homework using outer array L9, L8 and inner array L9, you reduce the number of samples. However, you almost get the exact same solution, right? You almost get the exact same solution as our inner outer array combination by using a much smaller number of samples. This is the purpose for compound noise factors. Any questions? So go back to the homework. I believe you can finish all of them, right? We find out which scaling factors, and we first know could use B, but you find out B is not good because B, when we adjust B, will go out of bound, so we can only come to the second best choice. We choose L, but you need to explain in your homework, okay? So we choose L, right? We choose L, then we choose L to be 50.01, therefore the average will be right on the target. And SN ratio only drop a little bit. Now you want to compare, okay? The initial design and optimum design in the SN ratio. You find out that our optimum design has a better SN ratio than the initial design. And you compare our optimum design with the inner array. We have L9 inner array, right? You find out that it is better than any of the current design. So we make sure that, oh, good, our design is better than all the samples in our inner array. Because we are using fractional design, remember? We didn't do the full factorial. We only use a small samples of orthogonal array to predict which one in the full factorial will give us the maximum SN. Therefore, even though we didn't do the full factorial, but at least when we compare with the L9, we can still confirm that our optimum design after the second stage optimization still have the best SN ratio. All right, P, I already did that. Compare with homework number 4. using inner outer array. All right, I already show you. For the outer array, 72 samples. Have to plus. Plus what? Maybe we need to also plus. There's something we didn't compare, but we need to plus. This is not just 26 and 72. You need to plus what? Try and error, right? You need to plus a try and error in the second stage optimization. But we didn't know how many try and error you did, right? So we didn't compare that. And after that, you need to plus what? Confirmation. Confirmation of our result. What? The confirmation of the optimum. See, in our experiment design, there's no initial, no optimum. So we need to confirm this result. Confirm that, confirm this one, because this may not be one of the designs. So we need to do the experiment on the maximum, do the experiment on the initial if you want to compare your result. And also, you need to do a lot of try and error in the second stage optimization. So no matter which design you use, outer array or compound noise, they all need to go through these two verification and that try and error process. Okay? Try and error process, they will be the same. But in our initial investment for the samples, outer array need 72. Compound noise only L8 plus 18, which is this one, 26. Okay, so you explain what you did in homework, and this will finish that homework number 5. Any questions? Okay, this will conclude our lecture today.